CS 3451 Introduction to Operating System. The topic is deadlock, presented by Anuja R. APCSE, Rohini College of Engineering and Technology. What is a deadlock? A deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource occurred by some other process. The real-time example of deadlock is two trains are traveling on different tracks. If a crossing came, a train must hold and wait for some time to continue the journey. That waiting situation is referred as a deadlock situation. While playing a chess, checkmate is the deadlock situation where there is no chance of escaping and have to hold or some time to move. Deadlock situation in database. So this is the block diagram for deadlock situation in database. Process A, process B, resource X and resource Y. While we are in no two transactions take place at a time in the database, it hold a transaction in a queue to proceed. The condition for deadlock in operating system, the following conditions are mutual exclusion, hold and wait, no preemption and circular wait. Deadlock prevention. At least one of four deadlock condition is never satisfied. So the elimination of deadlock prevention is it is a mutual exclusion, hold and wait condition, no preemptive condition and circular wait. Then the mutual exclusion means we can deny this situation by simple protocol, that is convert all non-shareable resources to shareable resources is also called as a mutual exclusion. Hold and wait, we can deny the situation with the following protocols. A process can request the resources only when the process has none. Each process to request and be allocated all its resources before it begins execution. No preemptions means we preempt the desired resources from the waiting process and allocate them to the requesting process. Circular wait, the numbering all the resources types and each process request resources in an increasing order of enumeration is also called as a circular wait. In deadlock avoidance, deadlock can be avoided if the certain information about process are available to the operating system before allocation of resources. For every resource request, the system sees whether granting the request will cause the system to enter an unsafe state. That means this state could result in the deadlock. This system, they can only grant the request that will lead to safe state. The deadlock avoidance algorithm is single instance of a resource type, use of resource allocation graph, and multiple instance of a resource type. It also used as the example for the banker's algorithm for deadlock avoidance. Allow system to enter deadlock state and deduction algorithm, and also used to recovery scheme. And the deadlock detection, once the deadlock has been detected, some strategy is needed for recovery. The various approaches of recovering from deadlocks are, one is process termination, another one is process preemption. So this is the graph while we are using in a deadlock detection. Deadlock recovery. So deadlock recovery is the process abort one process at a time until the deadlock cycle is eliminated. The process termination occur when the process is terminated. The exit system call is used by most operating system for process termination. This process leaves the processor and releases all its resources. In which order the following points that while we are recovering the deadlock is priority of the process. The second one is how long process has computed and how much longer to completion. Then resources the process has used, the resources process need to complete, and how many process will need to be terminated, and its process interactive or batch. In deadlock recovery, recovery from the deadlock resource preemptions, it can be divided into three parts, that is selection, a victim, The selection a victim is nothing but it is the minimize the cost. The second one is rollback, return to some safe state, restart process for the state. Then starvation means same process may allows be picked as victim, include number of rollback in cost factor. Thank you.